Swastiastu. Hello everyone. My name is Wayan Agus Darma Putra. My name is 211-3011-052. I am from 4A Mathematics Education. Today, I will do presentation about limit theorems. Okay, I will start the presentation. Okay, the first theorem of limit of a constant. The limit of a constant is itself. If a is a constant, then the limit of a as x approaches c is equal to a. The example is the limit of 3 as x approaches 2, the answer is 2. Another example is the limit of 1000 as x approaches 0 is equal to 1000. And there is the last example. The last example is the limit of p as x approaches 1/2 is equal to p. Okay everyone, let's move to another theorems of limit. Theorems 2. Limit of an identity function. The limit of a function of a function f of x equal x as x approaches c is equal to x. That this is simple. We have the limit of x as x approaches c equals c. For example, we have the limit of x as x approaches 0, the answer is 0. There is another example. The limit of x as x approaches 1/2 is equal to 1/2. And there is the last example. The last example is the limit of x as x approaches 3 is equal to 3. So, if you are given an identity function f of x is equal x or y equal x, the limit of x as x approaches c is just equivalent to value of c. Okay everyone, let's next the another theorems. There is a theorem of limit, theorem 3, limit of the sum and difference of two functions. This states that the limit of the sum of difference of two functions is simply the sum of difference of the limit of the individual function. Okay, there is for example. The example is we are given to the limit of f of x as x approaches c equals L, and the limit of g of x as x approaches c equals m. Then the limit of the sum or difference of these two functions is denoted as the limit of f of x plus minus g of x as x approaches c equals L plus minus m. To illustrate this, let's have an example. If the limit of f of x as x approaches c equals 5, and the limit of g of x as x approaches c equals 3, then the limit of f of x plus g of x as x approaches c, we just need to add the limit of the individual function. So we already have the value of the individual limit. So we have 5 plus 3 equals 8. Therefore, the limit of quantity of f of x plus g of x as x approaches c is equal to 8. Okay, let's move to another theorems. Theorem 4. Limit of linear function. The limit of linear function f of x equals m of x plus b, where m and b are any constant. We say that the limit of mx plus b as approaches c is equal to mc plus b. What happens here is that m and b return since they are constants value, and the value of x in your function becomes c in your answer seen as what we had discussed in limit theorems. Number 2, or limit of an identity function. The limit of x as x approaches c is equals to c. Therefore, the limit of mx plus b as approaches c is equal to mc plus b. Okay, to understand these theorems, let's have an example. If we are asked to solve for this limit, the limit is of 2x plus 3 as x approaches 3. Then, what we need to do is to substitute 3 to the value of x, since the limit of x as x approaches c is equal to c. So, we have here the constant 2 times the value of x, or the value of c, which the limit of x as x approaches c, so times 3, plus the limit of the constant itself. So we have plus 3. 2 times 3 equals 6, plus 3 equals 9. Therefore, the limit of 2x plus 3 as x approaches 3 equals to 6. Equal to 9. This is simply substitution, or this one method what we have discussed in our previous video, which is the substitution. So everyone, we move to another theorem and the last theorems. Theorem 5. Limit of the product and quotient of two functions. This states that the limit of the product or quotient of two functions is simply the product or quotient of the limit of the individual function. Okay, in symbol, we say that if the limit of f of x as x approaches c equals L, and the limit of g of x as x approaches c equals m, the limit of f of sig of x times g of x as x approaches c is equal to the product of their individual limits L and m. So L times m and the limit of f of x over g of x as x approaches c is just equals to the quotient of the limit of the individual function. So we have L divided by m, or L over m, such that the limit of the denominator should not be equal to 0. In case where the denominator is 0, the limit does not exist. To To understand these theorems, let us have an example. The limit of f of x as x approaches c is equal to 6, and the limit of g of x approaches c is equal to 3. So, if we are asked to solve for the limit of the product of f of 6 times g of x as x approaches c, we have to multiply their individual limits. 6 and 3 equals is 18. Therefore, the limit of f of x over g of x as x approaches c is equal to 18. Okay, so that's and about my presentation about the limit theorems. If any mistake in my presentation, I apologize. Thank you, and Om Santi 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 Om. See you next time.